Alright everyone, welcome back to the day 32 of our daily leetcode challenge, and today we have got special array 1. So let's understand the question. In this question they have provided us with an array and it can have numbers either even or odd. So let's say we have an array of size 5, then it can have numbers like these, and we need to find if array is special or not. And in the given question there is a special condition where that makes us array special if that every adjacent pair, as in like this is an adjacent pair, this is an adjacent pair, this is an adjacent pair, and this is an adjacent pair, every adjacent pair should have different parity. So what do they mean by the term different parity? When they say two numbers having different parity, meaning number x and number y have different parity if x is odd and x is even, and this could be vice versa as well. This could be opposite as well, like x could be even and y could be odd, meaning both the numbers should not be either even and both the numbers should not be either, both of them should not be even and both of them should not be odd. They should have different parity. So if x is odd and y is even, that would mean that they have different parity, and if x is even and y is odd, that would also mean they have different parity. However, if x and y both are odd and x and y both are even, in that case that would mean they have the same parity. So the condition where both of them are even or both of them are odd would mean that they have the same parity, and that is the case when we will return false. These two conditions will be a false condition, like any two adjacent number in the array, be it these two or these two or these two, these are all adjacent pairs, they should have different parity, mean either one could be odd, the other could be even, or one could be even, the other could be odd. These two conditions will lead us to a true. And the other special condition, if the length of the array is just 1, then there is no adjacent pair to form. In this case we'll just return true, which we saw in the first example. But if we take a look at the third example, which is 4 3 1 6, so let's try to form all the adjacent pairs. If we try to form all the adjacent pairs, we'll see 4 3 is a pair, 3 1 is a pair, and 1 6 is a pair. Now 4 and 3 have different parity because 4 is even, 3 is odd, so this is true so far. 1 and 6 have different parity, 1 is odd, 6 is even, this is also true. But 3 and 1 does not have the same different parity because 3 and 1 both are odd. If this pair would have been looking something like this, 2 comma 8, imagine these two numbers are 2 comma 8, in that case 2 comma 8 would both be still be even, and this will still be a both even condition, meaning both the numbers have same parity, so this would also be a false case. So this is what we need to check for each adjacent pair. We have to just check if one is odd and the other is even, or one is even, the other is odd. Basically it should not be same, both them should not be both even or both odd. If that's the case, we return false, and if it's the opposite case, we'll return true. So this is how the question is working, this is what they want us to do. Now how we can do it, what we can do is we can run a loop up till this index, which is the n-1 index, and for each index we are at, to get the adjacent pair, each index I we are at, to get the adjacent index, you can do an I plus 1 operation to get the adjacent value. So let's say if the length of array is 5, we are going to iterate from 0 to 4, n-1, and for each index which is I, we are gonna take the adjacent pair with the I plus 1. So in that case we will be forming all the adjacent pair. The reason we are doing n-1 is because if we reach the nth index, like in this case, we are going to be doing it up till n-1. So the length of the array is 5. Let me redraw everything here. So how this loop is going to work is, we will be taking, let's take the third example again, 4 3 1 6. In this case the length of the array is 4, and we will be iterating from 0 to n-1, which is 3. So the effective values which we will be traversing will be 0, 1 and 2, because the loop will end on the last. 0, 1 and 2 are the values we will be iterating. So which means 0, 1, 2. This is the third index. We will be iterating up till here, including 2. Why so? Because for each index I, which will be ranging from 0, 1, 2 inclusive, the I plus 1 value will be the next one. For 0, the I plus 1 will become 1. One adjacent pair we got. For 1, the I plus 1 value will be 2. So the next adjacent pair we got. For 2, the I plus 1 value will be 3. The reason we are going up till I n minus 1 is so that we can also include this and not go out of bound, because if we reach 3, the I plus 1 value will go out of bound. We don't want that, so we are terminating the loop at n minus 1. So this is how we will be forming the adjacent pairs. This is how we will be forming the adjacent pair, and simple check we'll have to do is if both these values I and I plus 1 should be different parity, meaning one could be odd, the other could be even, or one could be even and the other could be odd. Alright, so let's try to quickly code this up now. We'll be iterating up till the length of nums minus 1, and we'll be getting two values, the nums at index r and the r plus 1 index value. This is why we are reaching up till length of nums minus 1, so that we don't go out of bound. Now the condition of two values having same parity is that they could both be even or both could be odd. So if this is a check where we are doing if both are even values or if both are odd values. If this is true, meaning both are even or both are odd, in that case we'll have to return false, because this is the case where the parity is same. And if it's all goes well, we'll just return true in the end. Let's try to run this up now. So as you can see, the test cases are passing even for the value which has num1 index, and yeah, that's pretty much it. This is the algorithm that we discussed in the drawing as well. This is a O of n solution, linear solution, and it's beating almost all the solutions right here. So that was it for today everyone. I'll see you in the next one. Like and subscribe. Bye.